Hello students, welcome to the video on the MOSFET current voltage characteristics. So here in this video we will be discussing about the current and voltage characteristics of a MOSFET, how a current varies with respect to the applied voltage. So in the previous videos we have discussed about what is JFET and how it works along with its characteristics curve, and also we have studied about the mass capacitor and the structure of the MOSFET. We have seen that the MOSFET consists of three terminals or with one more like the body. We will be having a body is the other terminal, fourth terminal. So here we will be studying how the current varies with respect to the applied voltage. So here we know that we will be having three terminals, that is one is drain, then the other source and the gate terminal. Also we have studied there will be two different voltage, that is one is the gate to source voltage and the other one is the drain to the source voltage. So based on the applied voltage, the current through the device will be varying. So the VGS is used to change the operation, or I can say that it is used to change the depletion region, or the channel which is formed here in the device. So here when my VGS is greater than the threshold voltage, that is when VGS is equal to is greater than VT, the channel the device will result in the formation of the inversion layer. So once the inversion layer is formed, a path is established between the drain and the source. So now the channel acts as an resistance, and it is a voltage control resistance. That is, if I increase the VDS, my output current will be changing. That is, now the resistance, I mean the device will be acting as an resistance, or it will be in the linear region. So the first condition is when I apply an VGS voltage greater than the threshold voltage, the channel is formed and hence the device acts as an linear region. Acts in the linear region. And the second one is when I increase my VDS value for the given VGS, now the depletion region will be or the channel will be getting modulated. The channel will get modulated based on the applied drain voltage, and because of that there will be an change in the linearity of the device, and hence now current will be increasing with respect to VDS. And when still if I increase my drain voltage, there will be an larger VDS. We can see that the pinch of point occurs. The pinch of point is nothing but the point at which the channel gets narrower, and it almost touches the drain region, and hence because of that then the device now will start entering into the saturation region. So larger the value of VDS, when it is greater than VDS saturation, now there will be the channel will be cut off from the drain region, and hence there will be a constant current flowing through the device, and hence the device is said to be in the saturation region. So we will be having, based upon the applied drain voltage, with the channel will be getting modulated, and hence the current flowing through the device also. So when I take the characteristics of the MOSFET, we can see that the applied VGS in the first curve, the applied VGS will, when it is greater than VT, will result in the variation in the current in the MOSFET. So here we can see that as VGS increases, my various for various values of VDS, we can see the current. The transistor will be initially in the cutoff region, followed by the ohmic region and the saturation region. And for various values, as VDS increases, my current will be increasing linearly in the first case, and then it gets saturated in the saturation region. And for the N channel enhancement type MOSFET, it will be in the positive side, because a positive voltage of VGS will result in the channel formation, and hence the VDS also will be positive in this case for the N channel. Similarly, if I go for an P channel enhancement type MOSFET, so here the channel will be formed for the negative gate voltage. So my VDS will be equal to, it should be greater than minus, or it should be less than minus VT for the channel to be formed, and also my drain voltage will be in the negative in order to get my current. So here the operation will be similar to that of the N channel. The only thing is the voltage polarity will be getting changed. Similarly, if I go for the depletion type MOSFET, so we assume that the channel is formed even for the negative voltage, and hence the applied voltage will the applied positive voltage for the n channel depletion MOSFET will enhance the channel property, and hence because of that the VT value can be found to be it starts from the negative side. Similarly, for the depletion channel yeah, P channel depletion type MOSFET, the curve can be starting from positive value of VT. So at when VT is equal to 0, that is the channel will be getting depleted, and hence again the channel will be formed. So this results in the same curve similar to that of the enhancement mode. The only thing is the voltage, the channel exists for negative value of VT itself. So in this video, we have discussed about the various characteristics curve of the MOSFET, from enhancement MOSFET as well as depletion MOSFET. So this completes the topic on the MOSFET. Thank you.